Space is a hostile environment. Out of billions of celestial bodies scattered across the freezing void, we only know one that actually supports life. To find out why, we look in our cosmic backyard at the inner rocky planets, Mercury, Venus, Earth, and Mars. Together, they form a perfect control group. A logical assumption is that a planet's surface temperature is dictated entirely by its proximity to the sun. Get closer, it gets hotter. Move further away, it gets colder. But Mercury breaks that rule immediately. It orbits closest to the sun, reaching 430 degrees Celsius during the day. Yet at night, temperatures plummet to minus 180 degrees. It swings wildly between boiling and freezing because it completely lacks an atmosphere. Then there is Venus, the second planet from the sun. It actually holds the title for the hottest planet in the solar system. Its surface sits at a scorching 464 degrees Celsius because a thick, dense layer of carbon dioxide permanently locks heat in. Moving past Earth, we find Mars. It sits relatively close to us, and physical evidence proves it once held flowing water. Today, its atmosphere is so thin that the surface remains a frozen red desert. Distance from the sun does not guarantee a habitable temperature. A planet's survival relies on a highly specific combination of active, hidden mechanisms working together. The first requirement is the habitable zone, often called the Goldilocks zone. This is the specific band of space around a star where the temperature is exactly right for water to exist as a liquid. Our planetary neighbors miss this mark. Venus boils right on the inner edge of this zone, while Mars freezes on the outer boundary. Earth sits perfectly in the middle. This precise placement allows water to remain liquid and pool into the vast oceans that cover 71% of our surface. But sitting in the right spot means nothing if the planet cannot stay there. The shape of a planet's orbit is just as critical. If a planet follows a highly elliptical or oval-shaped orbit, it gets dragged in and out of the habitable zone. It boils as it swings close to the star, and then ices over as it travels far away, creating lethal seasonal extremes. Earth travels in a nearly perfect circle. Our distance from the sun remains relatively constant throughout the entire year. That stable circular path provides an uninterrupted baseline. It keeps our water liquid, allowing complex life the time and stability it needs to evolve. Once a planet has liquid water, it needs to regulate its temperature. That job falls to the atmosphere, a surprisingly thin layer of gas hugging the rocky crust. This diagram illustrates the natural greenhouse effect. Trace gases in the air, like carbon dioxide, act like a thermal blanket. They allow solar energy in, but trap the reflected heat from escaping back into space. Without this atmospheric blanket, Earth's average surface temperature would plummet to a freezing minus 18 degrees Celsius. Because of it, we maintain a comfortable global average of 15 degrees. We have already seen what happens when this mechanism goes wrong. Venus experienced a runaway greenhouse effect, where an overly dense carbon dioxide atmosphere trapped too much heat, creating a boiling environment. Earth's natural greenhouse effect is essential for our survival. However, human industrial activity, like burning massive amounts of fossil fuels, rapidly injects unnatural amounts of these greenhouse gases into the air. The atmosphere functions as a highly sensitive planetary thermostat. It only keeps the Earth habitable as long as its chemical balance remains undisturbed. Even with the right orbit and a balanced atmosphere, Earth faces severe threats from deep space. The sun constantly fires off barrages of high-energy particles. This stream of charged particles is known as the solar wind. If left unchecked, it has the power to strip away a planet's protective atmosphere, layer by layer. Earth survives this onslaught because of a hidden defense mechanism, a giant magnetic field. Generated by the continuous movement of molten iron in the planet's core, this field acts as a massive deflector shield. If that magnetic dynamo ever stopped, we would share the fate of Mars. Mars once had a thicker atmosphere, but it lost its magnetic field long ago, allowing the solar wind to blow its air into space. Our habitability is actively defended. This magnetic armor ensures our life-giving air isn't annihilated by the very star that warms us. When you look at the full picture, you see a strict set of requirements. We have the optimal distance from the sun, a stable circular orbit, a chemical thermal blanket, and a magnetic shield. Together, these cosmic conditions allow for the existence of our vast surface oceans. Those oceans then provide thermal inertia, absorbing and distributing heat to further regulate the global climate and prevent wild temperature swings. Earth's ability to host life is a highly precise, interdependent machine. Remove just one gear, like the magnetic field or the circular orbit, and the whole system collapses. Yet human activities actively threaten this finely tuned balance. Severe air pollution and the rapid emission of carbon dioxide place immense stress on the exact systems that keep us alive. Earth is a rare masterpiece of cosmic engineering. Understanding exactly how fragile these interlocking systems are is the first step in taking responsibility to protect them.